these video segments, I try to be relevant, to discuss studies that have an immediate impact on patient care. But sometimes a study comes along that is just so cool that I can't help but tell you all about it. Let me start with a question I'm sure you've asked yourself hundreds of times. Why don't all the elephants have cancer? Cancer is, broadly, a stochastic phenomenon. For cancer to occur, a cell in the body has to suffer just the right kind of DNA damage and subsequently escape detection. The chance of this happening in any given cell are extraordinarily low, but, well, there are a lot of cells. Time is a factor here too. The longer a cell is around, the more chance it has to accumulate mutations that might cause cancer. Elephants have way more cells than we do, by a factor of about 100. And their lifespans are quite similar, which brings us back to our main question. Why don't all the elephants have cancer? To figure out what's going on, researchers from the world over collaborated on a study appearing in the Journal of the American Medical Association that investigated the cancer incidence in over 36 mammalian species of varying sizes and lifespans, from the striped grass mouse to the fennec fox, from the marmoset to the tiger, the capybara, and of course, the elephant. Overall, the rate of cancer didn't vary much with body size or lifespan. Tasmanian devils, prairie dogs, and cheetahs had fairly high rates of cancer, but there wasn't a single moose with the disease. Elephants, the biggest and longest lived of the lot, had a lifetime cancer incidence of around 4%. You can compare that with the risk in humans, which is something like 10 to 20%. Genomic analysis then revealed the elephant's secret. Instead of 2 copies of the tumor suppressor gene TP53, they had 20. Over their evolutionary history, 19 extra copies of the gene had crept in. TP53 is a critical tumor suppressor. Humans lacking just 1 copy of TP53 have over a 90% lifetime risk of cancer. What's more, those TP53 genes appear to be more active in elephants. When exposed to DNA-damaging radiation, elephant lymphocytes killed themselves at a much higher rate than human lymphocytes. So the great mystery of the cancer-free elephant is solved, but a greater question remains. Why do humans only have 2 copies of TP53? One answer may be that up until modern times, we simply didn't live long enough to put any selective pressure on genes that would prevent cancer. Also, as we don't reproduce into our 80s, like elephants do, natural selection doesn't get a chance to provide new protection. In any case, this isn't a study that is likely to change practice in our nation's hospitals and doctors' offices, but it's certainly one I will never forget. For MedPage Today, I'm Perry Wilson.